Hello everyone, this is John Paul Jung. We will study I2NSF capability Yang data model. This course is data modeling and remote control for networks and security. This is John Paul Jung. This figure shows I2NSF framework in terms of architecture. So basically, it has three layers: security client, security management system, security network. Okay, security network is consists of multiple network security functions, NSFs, like firewall, web filter, deep packet inspection, antivirus. And in the middle layer, this is a security management system, having security controller, developers management system, or vendors management system, and I2NSF analyzer for data analytics. Okay, and the I2NSF user is dashboard used by the network or security administration or administrator. So I2NSF capability Yang data model is the base data model for other I2NSF the interface data model, like consumer facing interface, registration interface, analytics interface, and NSF facing interface, monitoring interface. They are have their own the Yang data model. So capability Yang data model is a basis for them. So I am editor for this document. This is approved as a RFC for Internet Standard by IETF. Okay. So introduction to capability Yang data model. This document specifies the information and data models of the capability of network security functions and FSs in a I2NSF framework, specified RFC 8329. NSF produced by multiple security vendor like Symantec, McAfee, something like that, provide the various security capabilities to customers. So multiple NSFs can be combined to provide security services like a firewall, web filter, intrusion detection, deep packet inspection, and antivirus over the given network traffic, regardless of whether the NSFs are implemented as a physical or virtual functions. Okay, and security capabilities describe the functions that network security functions NSFs can provide for security policy enforcement. Every NSF should be described with a set of capabilities it offers. So we have a Yang data model. This Yang data model uses an event condition action ECA policy model that is used as the basis for the design of I2NSF. So IETF I2NSF capability, this Yang module defined in this document provides the following features: event condition action. Also, some condition conflict resolution strategy is specified. Also, default action specified if there is no specific action specified in the policy rule. So design principles, some basic design principles for security capabilities and the system that manage them. Independence. Each security capability, such as events, conditions, actions, should be an independent function with a minimal overlap or dependency on other capabilities. This enables each security capability to be utilized and assembled with other security capabilities together freely. More importantly, changes to one capability should not affect other capabilities for independence. This allows the single responsibility principle. Abstraction. Each capability must be defined in a vendor-independent manner, and the specific function can be implemented by vendor. Advertisement. The registration interface must be used to advertise and register the capability of each NSF. Okay, so registration interface Young data model. This is import capability Young data model. Okay, to register each capability, also network access information like IP address and port number. This interface must be used by other I2NSF components to determine what capabilities are currently available to them. Some basic design principles for security capabilities and systems that manage them are as follows: execution, automation, and scalability. So execution. The NSF face interface and the NSF monitoring interface must be used to configure the use of capability into an NSF and monitor the NSF respectively. These provide a standardized ability to describe its functionality and report its processing result via monitoring interface respectively. These facilitate multi-vendor interoperability. Automation. The system must have the ability to auto-discover, auto-negotiate, and auto-update the information of an NSF's registered security capabilities without human intervention. This is automation. These features are especially useful for the management of a large number of NSF in a data center, something like that, or cloud computing environment. They are essential for adding smart devices or smart services such as refinement, analysis capability, reasoning, and optimization to the security scheme employed. Scalability. The management system should have the capability to scale up and down or scale in or out. Thus, it can meet various performance requirements or character of service derived from changeover network traffic or service request. In addition, security capabilities that are affected by scalability changes should support reporting statistics to the security controller as a brain in the I2NSF framework to assist its decision on whether it needs to invoke scaling or not. So first of all, remember, event condition action is a specified policy. Okay, so we have this ECA policy model. The event condition action ECA policy model in this document, okay, is used as the basis for the design of the capability model. The following three terms define the structure and behavior on I2NSF imperative policy rule. Okay, imperative is a kind of specific rule. Okay, event. An event is defined as an important occurrence in time of a change in the system being managed and or in the environment of the system being managed. Okay. For example, when used in the context of I2NSF policy rules, it is used to determine whether the condition clause of I2NSF policy rule can be evaluated or not. So, which means event and condition combined. Okay. So, under specific, the event condition clause can be evaluated. Okay. Examples of an I2NSF event include time and user actions, such as login, logout, and actions that violate an access control list (ACL). And condition. A condition is defined as a set of attributes, features, and or values that are to be compared with a set of known attributes, features, and or values in order to determine whether the set of actions in that imperative I2NSF policy rule can be executed or not. So determine the condition for specific action. Examples of I2NSF conditions include matching attributes of a packet or flow, header, or contents information, and comparing the internal state of an I2NSF with the desired state. Okay. The action is used to control and monitor aspects of I2NSF NSFs to handle packets or traffic flows when the event and condition clause are satisfied or met. NSFs provide the security functions by executing various actions. Okay, so examples I2NSF actions include providing insurance detection or protection, web filtering, URL filtering, flow filtering, defect inspection, antivirus. Okay, and then depending on this, and this is a forward or drop or mirror or copy or tunnel to a certain another or forward using service function chaining SFC. So we have a specific example for I2NSF policy rule. We said each policy consists of event, condition, action clauses. This structure is called the ECA policy rule. The Boolean clause is a logical statement that evaluates to either true or false. It may be made up of one or more terms. If more than one term is present, then each term in the Boolean clause is combined using logical connectives and or not operator. On I2NSF ECA policy rule has the following semantics. So event clause evaluated is true, and then condition clause is evaluated, it is true, and then execute action clause according to event, condition, and clauses. Okay, so constrained by metadata. So consider so certain cases some conflict happen, so we need to resolution strategy for the confliction, so or conflicts. Okay, so consider two rules, R1, R2. During 9 a.m., 6 p.m., allow John to access the social networking service website. Rule 2, during the same period, disallow all users to access social networking. So in that case, John also cannot or can. So somehow we need to allow. So John case how can handle. The two policy rules R1 and R2 are now in conflict between the hour duration 9 a.m. through 6 p.m. because the actions of R1, R2 are different, right? So John case access SNS service, R2 case all user cannot access during this time, different, okay? But apply to the same user, John. So conflicts theoretically compromise the correct function of a device. Since conflicts are originated by simultaneously matching rules, an additional process decides the action to be applied among the actions which the matching rule would have imposed. So this is called resolution strategy for conflicts. So we have several resolution strategies. First matching rule, last matching rule, prioritize the matching rule, prioritize the matching rule with no error. Okay, so according to this kind of rule we can handle. So for example, first matching rule case, order action by the order of input where the first input is matched and the first. Okay, last case, order action by the order of inputs where the last input is matched first. Okay, prioritize the matching rule case with errors. This is with no error, two cases, okay? So order by their priority values. If any action fails to execute properly, temporarily stop the execution of all actions. Invoke the error handler of the failed action. If the error handler is able to recover from the error, then continue the execution of any remaining actions. Else, terminate the execution of the ECL parcel rule having those all actions. The second one prioritized the version with no error case, order by their priority values. If any action fails to execute properly, stop the execution of all actions. Invoke the error handler of the failed action, but regardless of this result, the execution of the ECL policy rule having those all action must be terminated. So on the other hand, it may happen that if an event is caught, none of the policy rules matches the condition. A simple case is no condition in the rules may match a packet arriving at the border firewall. In that case, packet is usually dropped because of default behavior firewall. Packet dropping, okay? So dropping action is used in order to manage the cases that are not covered by specific rules. From now on, we'll see a young tree diagram of NSF capabilities, okay? So NSF, this is a module name, ITF, I2NSF capability, and NSF, okay? This is NSF name, okay? So this one container has this kind of thing, right? So NSF name, directional capability, event condition, advanced capability, context capability, action, resolution strategy, and the default action capabilities we discussed before, right? So the NSF capability in the tree includes those capabilities. Those capabilities can be tailored or extended according to a vendor-specific requirement. The I2NSF capability Young data model provides identities, okay, for the capability definition of NSF. Okay, so every identity in the data model represents the capability of an NSF. So event capability are used to specify capability that describe event that would trigger the evaluation of condition clause of I2NSF partial rule we saw just before. The defined event, system event, system alarm. So system event is a warning about any changes of configuration, any access violation in ACL access control list, the information of sessions and the traffic flows. System alarm is alarm related to service degradation in system hardware issue. Okay, so this is the event container. So the description references for this capability, and so event capability is implemented lip list, and system alarm lip list. Okay. Also, type is identity left system event. This one is system alarm. And the condition capability are used to specify capabilities of a set of attributes, features, and or values that are to be compared with a set of known attributes, features, and or values in order to determine whether a set of actions needs to be executed or not so that an imperative I2NSF policy rule can be executed. So two kinds of condition capabilities: generic default, these are normal NSF capabilities, and advanced NSF capabilities. Okay. Usually we just generic NSF capability good enough. Okay. Condition capabilities also provide context condition, which is the extra information for the execution of action. So generic NSF capability based on the layer 2, 3, 4 header fields information, right? So like this, we define container. So Ethernet capability, IP1.4, IP1.6, network layer capability, ICMP version 4, version 6 capability for Internet consumer message protocol, and the TCP, UDP, SHTP, DCCP for transport layer capabilities. So we can, according to layer header, we can specify generic NSF capabilities. Advanced NSF capabilities define NSF that operate on features different from the generic NSF capabilities, such as the payload, cross-flow state, application layer, traffic statistics, network behavior, etc. This document defines the advanced NSF into two categories, such as content security control and attack mitigation. So this is usually deep packet inspection, such as intrusion prevention, IPS, URL filtering, entry bias, and VoIP, the defense from the voice over IP attack, okay? Or VO shallow network, VOCN, VoLTE over 5G, okay? Filter. So looking at the content of payload depends, okay? The NSF network system. Attack mitigation is anti-DDoS attack. So DDoS attack is detected, mitigate the impact of DDoS attack. So container advanced NSF capability like this, okay? So anti-DDoS capabilities, IPS, antivirus, URL filtering, VoIP, VO shallow network, VOCN filtering capabilities, okay? Defined like that. And the context capabilities provide extra information for the condition. The given context condition are as follows: time capabilities, the application filter capability, device type capability, user condition capability, geographic location capability is used. Okay, so time is specified the capabilities which describe when to execute the I2NSF policy rule. The time capability are defined in terms of absolute time or period time. This periodic time is a kind of repetition of the context. So handle periodic time, like some weekday work time, employee cannot access SN service case. This kind of period capability can be used. Where the absolute time means the exact time to start and end, and the periodic time means repeated time like day, week, month, or year. And secondly, application built capability is the capability for matching the packet based on application protocol like HTTP, HTTPS, FTP, etc. Device type capability is for matching the type of destination devices, such as a PC, personal computer, IoT device, Internet of Things device, network infrastructure devices. User condition capability for matching the users of the network by matching or mapping each user ID to IP address. Users can be combined into groups, so we can have a group of users. Geographic location capability for matching geographical location of a source destination like SKKU Suwon campus. Okay, so container context capability has a time, application filter, device type, user condition, geographic capability. We can specify. And action capability are used to specify the capability that describe control monitoring aspects of flow-based NSFs when the event and the condition clause are satisfied or met. So we have three kinds of action capabilities: ingress, egress, log. So ingress case, packet is enter the network, and then we can handle the traffic, okay, to provide secure the network. Egress case, NSF forward the next hop and handle the outgoing, okay, security service. Login case, we just log packets and trigger rules, okay. So action capability container contains ingress action, egress action, log action. So examples of NSF capabilities, okay. So this example shows the computer XML for capability restoration of a general firewall as an NSF IP version 4 network, okay. So like this. So this is for the netconf, right, case, this kind of domain, the scope namespace used, right. And this is NSF name general firewall, and the condition capability action capability, right. So version 4 is next header, extension header used, flow direction, source address, destination address, source port number, destination port number, and the UDP, TCP are specified, okay, differently handled. This is generic. And the action case, pass, drop, meter, pass, drop, okay, meter, okay, ingress, egress, separately we can specify it, okay. So this is a general firewall version 4 protocol, and NSF can handle TCP UDP port numbers, version 4 source IP addresses, flow direction, some header field value can be evaluated. Also NSF can control whether the packet pass, drop, meter, okay, ingress or egress. Version 6 case also similarly, okay, we can define, okay, version 6, yeah. And then so time-based firewall case, we can specify the time, absolute time, periodic time, okay. So and then for example work time, some company employee cannot access SNS service, so we can specify the periodic time, okay. And then web filter. So web filter case, we can specify the web filter for SNS service I mentioned. So the web filter case, a URL filter capability user defined, okay, URL domain should be used for matching. So the name of NSF is a web filter. NSF can inspect the URL matched from user defined URL. User can specify their own URL like a domain name. And the NSF can control whether the packet are allowed to pass or drop here, okay. Ingress, egress, we have both actions. Overall, the NSF can compare the URL of packet to user-defined database having some URL information. The matched packet can be passed, dropped, or mirrored. And now we have a voice over IP service, voice over IP or voice over serial network for 4G LTE and 5G filtering. So NSF inspect the voice core ID, inspect some malicious user. NSF can control whether the packet pass, drop, meter, ingress, egress actions. And the DDoS distributed denial of service, the DDoS attack mitigator case also we can specify here. So advanced, this case advanced NSF, right? So advanced NSF capability specified. So detect, okay, DDoS attack using packet rate, byte rate, flow rate. Okay, this is a condition detect DDoS attack, and the action is ingress, egress, pass or drop. Okay, so and then we can control DDoS attack traffic. Conclusion: I2NSF capability young data model specifies the information and data models of the capability of network security functions NSFs in a framework of I2NSF interface to network security functions. The event condition action ECA policy model is used as the basis for the design of the capability model. The data model introduces two further capabilities for an NSF to handle security policy conflicts with resolution strategies and impose a default action if no rules are specified, okay, or no rule matches, okay. In this class, The usage of I2NSF above the young data model is shown with example for further I2NSF interface young data models. So thank you for your attention. If you have a question, please let me know. Thank you.